Okay, welcome everybody. So my name is Thomas Teusel. I'm a visualization scientist at the Visualization Core Lab here at KAUST, and I welcome you to this workshop on scientific visualization 101 with ParaView. It's going to be an introductory hands-on workshop, so you don't need to have any experience with ParaView. We'll go to some simple examples, and I'll show you essentially how to work with ParaView and what are the most basic and most important visualization techniques. Before we get started, I want to remind you that the best thing is if you have your laptops with you and you have ParaView installed, preferably the latest versions, which is 5.13. You can just go there and download it. Let me show you quickly. You will get to a web page, to the ParaView download web page. Depending on the operating system you're on, it will already have selected the correct operating system. If you are on Windows, I would recommend, first of all, an MSI, because then you get an installer, and secondly, not the MPI version. So just the regular Windows version for ParaView. Otherwise, you might get an error message that you don't have MPI. If you get that, just download the non-MPI version here. If you're on Mac, you have to know if you're on an Intel or on a Silicon chip, and if you do, I would also recommend, there you go, I would recommend a DMG, just that one to download it. I guess we don't have any Linux guys here, but there's just one version anyway. Okay, that's the first thing. So just make sure that you have ParaView installed if you want to follow along. The second thing is, you received an email earlier today with a link to the web page, workshop web page, and the workshop materials. I have updated some things since then. I apologize for that. So I want now everybody to delete whatever you downloaded before and just go there and download everything again. So what you need is actually just this last link here. This should be in the email you received, or you just type in wiki with KAUST edusa. Then you'll get to this page actually, then you can go to training events, and then you go to scientific visualization 101 ParaView, okay? Then you should go get to this web page here. And if you do that, here's the workshop materials. Please download. If you want to follow with the slides, you can download the slides again, keep it open in your browser, or download them somewhere, whatever. Make sure it says October 1st, 24. If not, refresh your page. You might still have an old version in the cache. And then you want to download the data sets. On Windows, there's a small catch. So if you go to your downloaded files, Windows does not automatically extract the files, and then ParaView won't find them. But it's not easy to see that they're not extracted. That's sometimes a bit confusing. So if you have it downloaded on Windows, only on Mac, it should extract automatically. Sorry. Just right-click and say extract all. You can extract to any location you want. Just make sure you remember which location it is and say extract. And then you should have your data sets actually as an extracted folder here. So you see the difference. This is actually the compressed files. This is now your folder. So that ParaView will find them later. Okay? Everybody up to speed so far? If I'm too fast, just say something. We have 2 hours. I can slow down. I can repeat things. If you're watching live, we're also streaming this live on YouTube. You can type in the chat, or if you want to type something in the chat here, you can do it as well, of course. My colleague here is monitoring the chat and might forward the question to me if he thinks it's important enough. Okay. A little motivation right ahead before we start. This is the data set we're going to work with. It's a simulation of the water movement in the area of the Gulf of Aden, actually. I have opened that here on Google Maps. You know where we are. KAUST is here, north of Jeddah, right at Tuval, right? That's where we are right now. and the Gulf of Aden is down here at the end of the Red Sea. This is this area. And researchers here at KAUST actually have numerically simulated wind, not wind, the water movement in this area together with salinity and temperature. So they want to find the relationship of how the movement of the water, especially the eddies in the water, influence the transport of salinity and temperature in this region. So if you look at that, this is exactly that region that we're gonna use in this as these examples. This is the data sets that you should have downloaded from the web page. We will open them later in ParaView and take a look at them. And some of the things we're gonna do is we're gonna do some simple. I'm gonna switch to laser point. Oops, not good. Sorry. Gonna switch to pointer mode here. Right. So what we're going to do is do some simple scalar visualizations, like simple color mapping, which you should be used from forest color maps, like you see on weather shows on TV all the time. That's a very simple technique to visualize scalar fields in 2D. We're going to take a look on how to make height fields out of them, how to do slicing inside through a volume, which the salinity is actually given in 3D throughout the whole volume of this Gulf of Aden. So we do some slicing, and then we can do some contouring of interesting regions. Or in this case, it's in terms of salinity, but we could also do that for temperature. And then afterwards, we're going to take a look at flow visualization techniques, simple ones like arrow plots. So there you see that how the water is moving here on the surface. Also arrow plots you can do in 3D to see the movement through the whole area of the Gulf of Aden. And then some streamlines over here. Okay. Just a little bit about that data set. This is actually a publicly available data set, which we have been using for what's called the SciVis contest 4 years ago. And it's available online, but it's actually a larger data set. So first of all, it simulates the whole Red Sea. And then it does that actually with 50 members, so that you can simulate some uncertainty, and you have it over time as well. So the whole data set is much larger. I've written it here. If you download it, it's only for 64 gigabytes, but if you then uncompress it, it will be 1.5 terabytes on your hard drive. So before you do that, make sure you have that space. What we're going to do today, actually, so I just extracted this smaller region here around the Gulf of Aden from one timestamp and one ensemble. And this is small enough that everyone should have a good enough laptop to do this today. Okay. This is about the data. A few people came, so let me just quickly repeat this here. Please, everybody, make sure you've downloaded ParaView if you want to follow on your laptops, and go to the web page. You should have received the link in the email and download all the data sets. If you've already done so, please do it again. I've updated a little bit just a few hours ago. Okay. And you can do that installing and updating, downloading everything. I'll give a short presentation now for 10 minutes, telling you a little bit about the lab and what we do and such things. So the actual workshop will start in about 10 minutes. And in the meanwhile, if you haven't done so, make sure that you have downloaded everything. So let me quickly tell you a little bit about the core lab, the visualization core lab. So we are a part of the whole core labs here at KAUST. We're a team of 6 people. Sohaib is the team lead. And we help researchers and students here at KAUST or in the kingdom with projects to visualize their scientific data. Okay, and we have several expertises in the lab. So Sohaib is a visual analytics person. James and I are the scientific visualization people, which means that kind of data that you've just seen, like simulations of physical phenomena, like water movement or wind or things like that. That's what James and I do. Ronel as well, but he also specializes in VR development. So if you're interested in doing things in virtual reality, you might want to contact Ronel. And we have 2 data scientists, Didier and Abdul Khafour, who are helping and working on data science and AI, machine learning. And they will also do workshops. I'll show that later, where you can learn things about that. Actually, I can use that, yes. So what we do is we, besides working on these things and doing workshops. No, actually, that's also here. Anyway, so we also have 2D and 3D visualization facilities that you can use. Good equipment, powerful equipment, and we help you or researchers with the visualization workflows. So if you have a bigger workflow or a bigger problem than what you see today or learn today, feel free to contact us anytime. We might be able to help you. And we do trainings and workshops on all these things that we have expertise in. And actually, we have done a few of these workshops lately, and you can find, especially the latest one, you can find all of them on our YouTube channel. That's the same channel where this one is being streamed live now, and also this workshop will be available afterwards. So if you want to watch something again, you can always watch it again on YouTube later. Probably starting with tomorrow. It will take a day or two until it shows up, the recording. This is what our facilities look like. So, for example, we have these HMDs, head-mounted displays for virtual reality. You put them on your head, and then you're completely inside a virtual world. For data visualization, for better appreciation of the spatial context of your data. We do have segmentation tablet specifics. If part of your work is to segment data, mostly usually volume data, if you don't know what that means, then no problem, then you're obviously not doing it. But if you do and you have a problem with that, feel free to contact us. We have specialized hardware to help you with these kind of tasks. And here you see one of these virtual reality, a larger virtual reality installation where we can do visualizations. And we have this big display wall. People here at KAUST know it from thread on the other side, where we can display large data and can use it as a collaboration space. That's what it looks like, for example. So, for example, you can bring up ParaView on that big display wall. That also has a high-speed connection to the supercomputers, IBEX and Shaheen. So it might be easier and faster to visualize things there. Or you can use it as a collaboration tool using a collaboration software called Sage 3. If you're interested in that, just check this out. And if you want to use it, let us know. And if you're here at KAUST, you can actually, if you know how to use it or you want to use it, book everything that we have. Going to this webpage, you have to log in with your KAUST credentials. And then you can book, for example, also this room if you need it for a presentation, if you want to do your PhD defense here, for example, or anything else. If you have an important visitor, you can use this room, book this room, and do a presentation. But you need to have KAUST credentials for that. So these are the upcoming training events that we do. Actually, not all of them are upcoming. A few already happened. 2 weeks ago, James did this similar workshop on Visit, which is also a tool for visualizing scientific data. You might want to check it out. October 1st, this is today, ParaView. Next week, Ronel will do a workshop on image segmentation and 3D analysis. So if this is part of your workflow, you definitely want to check that out. So for example, you're getting data from the imaging core lab, electron microscope data, things like that. You have to segment them. Then you might want to go to this workshop next week. If you're using IBEX and Shaheen, doing simulations or something, and you're producing a large amount of data, you want to somehow visualize that without actually copying everything to your own workstation. We have workflows for that, and especially there's an onboarding event next week, Sunday, which you definitely don't want to miss if you just want to use IBEX or Shaheen for anything. Just go there. This is most important that you know them, unless you've done it before. But if you have not used IBEX and Shaheen but want to use it in the future, go to this event on Sunday. Then we have data science workshops, so introduction to Shell, Conda, and Python. If you have to do these kind of things in your workflows, all of these workshops are similar to this one. Just an offer to you. No attendance required if you don't have time. Just if you're interested, come and learn something. And we don't provide any certificates, so there won't be any tests and nothing. So if you want to learn something about shells, how to use the shell, how to use Conda and Python, go to these workshops. If you're interested in machine learning, AI, go to the workshops on these topics starting next week sometime. And all of them, those that already have happened and those that will happen, will be available on our YouTube channel. Okay, so you can also just watch them online. So this brings me to today. This workshop, the goals. The goal for today for me is super simple. I want to show you how to use ParaView. It's in principle a regular GUI application like any else, but it has its little few pitfalls, which is easier to learn if someone just shows you the most important things. So these 2 hours, we just go through a few steps with one simple data set, and you learn how to use ParaView on that one. It's introductory, completely introductory, and I'll just use some slides and have my demonstration here on my laptop to show you these things. We'll have plenty of breaks, so if you have questions, you can ask anytime, but we will have I think, after each topic, we'll have a short break, and then you can also ask questions. And definitely afterwards, or anytime, if something crops up, shoot us an email. So a little bit about ParaView. ParaView is an open source software, so you obviously can just download it and install it. You can also just download the source and develop and program things yourself if you want to, if you're a computer scientist. But in principle, it's just an application that you can download for free. And it supports all kinds of visualizations, also big visualizations like distributed on a supercomputer. So if you're using IBEX or Shaheen, then ParaView is also a good tool for visualizing your data there. And it has actually a commercial maintenance and support from a kitware, so it's a pretty stable software which will be there for a while. So it's pretty safe to use for your research. And why do you want to use it at KAUST? Because we have it here and we have a lot of expertise. So we have it on all major computational resources, especially on IBEX and Shaheen. ParaView is installed there. And we can show you how to use it if you have problems. And we have expertise in the lab. So if you have any kind of problems, just let us know. A little bit of an overview of what ParaView can do. So what I want to point out here is that it's a general purpose data visualization tool, which is good, and you can see the examples here. For example, it goes from this is molecular data, so super small things from the nanoscale, over a simulation around a racing car or a tank, for example, so regular sized phenomena in the real world, to really large, or this machine, whatever it is exactly, some combustion simulations probably, to really large phenomena like this is some wind isosurfaces over the US, over North America, right? Even to global simulation of mantle convection. So ParaView can do all of these things, which comes with a few pitfalls, and we will see that later. But it means you're not bound to a specific tool that is specific for your kind of research. If you produce some kind of data that is 3D and ParaView can read it, then you can use it for visualizing it, whatever it is. And a little bit about the architecture. That's not so important, but I want to point out a few things. So it's built on a few low-level libraries that are not important. Important is it's in principle, it's built on something which is called VTK. That's the visualization toolkit, which you don't really need to know if you want to use ParaView, but it will crop up every once in a while because the data sets are usually called something .vtk, .vti for image files, .vts for structured files. So just in case you wonder why these files are named like that, it's because the data structures come actually from the visualization toolkit. And on top of that, important is that it's actually a client-server architecture. So there's a server layer, meaning that we can just install it on a supercomputer, run the server there, and then connect the client to the supercomputer, and don't have to copy the data when you want to visualize. And on top of all of that are several applications. One of them is ParaView client. That's the only thing that we're going to use today, which you're going to use if you visualize your own data. But you could use other things. You could just write Python scripts, for example. You could use an application that's called Catalyst to improve your workflows with a supercomputer and things like that. We're not going to look at these things at this workshop. We're just going to look at the ParaView client here today. And that's the agenda. Just a rough outline. I'm not going to stick to the minute to anything here. Just what I plan approximately to do, 15 minutes. I'm already over that for the introduction. Then a large part on scientific visualization for scalar fields, meaning phenomena like temperature and pressure, which are given by one real number. And then another large part on vector fields, things like wind and water movement, or electric current, electromagnetic current, whatever, electromagnetic fields, things that are described by a vector, essentially by three real numbers. And in the end, if we have time, I can go through a few things in the GUI, which we might not have covered through these 2 hours, which might be interesting or not. And then we should have enough time for questions if we have them, or discussions afterwards. Again, the motivation, show you a little bit quickly what we're going to do. We're going to do this data set and look at the scalar field visualizations and vector field visualizations on this simulation of water movement in the Gulf of Aden. Right. This is the point where I switch to my laptop. I have to turn it on. This is the next bit for Kick share quit unexpectedly. Of course. This is where my laptop should show up at some point. It does. Okay. So if you have downloaded ParaView and you just started, I assume that everybody knows how to start a program on the respective operating system. I have a MacBook here. On Mac, you press Command-Shift and you type ParaView, and then you can open it. I've already done that. It should look like this. And does everyone have it open or need some help for setting it up? Otherwise I will just go on and discuss a few things. Let me know if you need more time, okay? So this is what the ParaView looks like. Like I said, a regular GUI tool. You have menus and toolbars. We'll use some of that today. What's different from other applications is of course, you have this big display area here where your data will show up. If you just click into it with the left button, with the left mouse, I'm using actually the mouse pad here, which works too actually nicely. You won't see much because we're not showing any data yet, but you see that you're rotating your space by this little triad here, which shows your spatial axis in space. But that's of course not very interesting. So let's just, so that we have something to look at, let's just load our first data set quickly. As in most programs, just click open on the top left here. Can also go to file open, it's the same thing, or press Command O, all works the same way. You should get the file dialog. Now you should have remembered where you downloaded your data, and you should have these two files, bathymetry.vti and gulfofaden.vts. Okay. The very useful, in my opinion, is ParaView remembers the last few places where you've opened data. So if you're somewhere else, you've forgotten where your data was. If you used it recently, it's just there. You just go back. I would load now this bathymetry.vti. Just double click or select and press open. And the next thing that happens is again nothing essentially, and there's a reason for that. That's the first thing that most important in my opinion that they have to know about ParaView is whenever you do something, or most of the time when you do something, we'll talk a little bit about that later, you will have to hit apply that something happens. And I just figured out now I have forgotten a step. So for some of you, this might look differently. You have only 2 tabs here, is this right? Okay, then let me... another important button here is this one. If you hover over it, it says reset session. I do that now, I press it, it says I'm going to discard everything. I do that, I use that button all the time. I screwed up, I messed up something, I want to restart, I want to go from the beginning. I don't have to restart all of ParaView, I just press this button, restart session, say yes, I'm done. Okay, so this is a GUI layout. I would recommend that everyone changes this to these 4 tabs. I'm going to show you now how to do this. First of all, I think it's much more useful, and second, it's less confusing for you now if things look differently for you than for me. So to change this GUI layout here, go to the File and Preferences or Settings. Where is it? It's actually on Mac, it's under ParaView Preferences. On Windows, it should be the same, or it might be Settings or something. Let me know if you don't find it. You should get a dialog that looks like that. The next stumbling block is very weird that this setting, which I use all the time, is actually hidden under the advanced settings. So we have to select the advanced settings here with this gear icon, and then you have to scroll down and find this thing, which in your case probably says combined properties panels, right? And change it to separate panels for each type of properties. Okay, then press OK. You won't see any changes, you have to restart ParaView. I'll do that too. Now it should look something like that with these 4 different panels. I'll talk about those panels a bit in a while because they are very important, and I think it's much more useful if you have the 4 separate ones. Okay, everyone following so far? Just let me know if I have to slow down. Okay, so now let's go quickly, or let's go and load actually our data. Again, now I know I have opened my data already from here. So I press open, I select my data, press bathymetry.vti and select it. So again, nothing happens because whenever you load data, before ParaView will actually load the data, it will show you some overview of what your data is, what it contains, and you could do some changes and settings. The reason is that ParaView is designed to deal with large data. So if it would just load everything at once, it might crash, it might not be possible to load everything, or you don't want everything, meaning that whenever you load data and do some other things, you will have to press apply. So in our case, we don't want to change anything because this is small enough, we can load everything, and we can just hit apply. And then you should get something like this. Okay. So that's why it's called bathymetry. This is now a 2D scalar field because it's just over the region. At each position, it stores the depth of this region of the Gulf of Aden. So how far, how deep down how deep down does it go at each point? And ParaView automatically applies already a color map to it, which in my opinion is not very beautiful. And so we're gonna change that in a second. Sometimes it happens that some other tab, by the way, is open. I think I can show that if I delete. I can always delete. Yeah, okay. Let's go slowly. In the properties panels, you see your data essentially, what the data is, or how to load it. And then when you do it, it will show up here in the pipeline browser. So that's why we say here, oops, we have here now bathymetry.vti. This is just a file that we loaded. Pipeline browser is very important. It will show you essentially, yes. You cannot open the file. What's the problem? Can't you not find it? Or no, James can help you. That should be easy to fix. So in this pipeline browser is where you design your visualization pipeline, where you will apply all kinds of steps, all kinds of visualization algorithms. So that's good to know what everything means. And especially I can just delete my file again, unload it. I want to demonstrate if I, for example, in some previous workflow had my display open and then I load the data again. I'm not seeing any apply button, right? That might be confusing because the apply button is actually on the properties panel. So you have to switch them manually. ParaView will not do that for you. And then hit apply. If this hasn't come across yet, always hit apply. In ParaView, otherwise your data is not completely loaded. Something will be incomplete. Okay, so we have this bathymetry image now, and we have some color map applied to it. I don't really like that one. So let's just apply a different color map to it. And let's just see how that looks like. So it's this you can actually do on the display. Actually, I might wanna switch. My slides to this one. Yes. So on the display, you have this coloring section where you have lots of buttons. Okay, the first one is a selection button for which variable in your data set you want to actually use for coloring here, right? And in principle, we have only one option here because we have only one variable in there, which is the depth. But we could always color by just one solid color, which is not very interesting, and it doesn't even work. It should work, but it doesn't even work. So we actually select depth here. This is essentially the only color we have, or the only variable we have anyway. And the way to select a new color map is this button here, which is called Choose Preset. Okay. So if you press that one, you get a selection of color maps, and you can choose whatever you want. By default, ParaView presents a few which it thinks are most useful. But if you want to, so they are also grouped into some other kinds of types of color maps. And if you want to see all of them, you can see all of them by selecting them all. And then you see there are quite some color maps which you can use for this purpose. And I think, I don't know which one I like. In this case, maybe the rainbow desaturated. Looks at least somewhat psychedelic. Okay. Everyone able to change the color map so far? No? Let's, James, let's make a quick break, and let's fix all of these things, and we'll be back. Those people watching on YouTube, try to figure out how to change the color map, and we'll be back in about 10 minutes. 7 minutes, okay. So we're back online, right? Okay, everyone has managed to start ParaView, has the layout approximately like me here, if you want to follow, and has a color map changed, and is able to change color maps. So again, it's just here in this coloring thing, this one. But we take a look at the other buttons in a while, but they're not so important at the moment. So this one, you choose the color map. I like that one already. With this button here, you can turn on and off the legend. Usually, it's a good habit to have a legend that you know what your colors mean. If for whatever reasons you don't need it, you can turn it off here. Okay. Let's leave it for a moment. So let me go quickly back to actually this slide here. A little bit. I'm just showing my ParaView here on the big screen. You see my slides on the smaller TVs on the side. Online, you see the slides on the lower left. I want to quickly talk about what scalar fields actually are. I mentioned it a few times already, but the important thing also that they come usually in different domains, and that means that you use different techniques to visualize them. And I've shown them here on this slide. That if your domain is only a 1D domain, that's you have done that in school all the time, that you just plot a graph of that function. That's essentially, you can think of that as a simple visualization. For example, here you have some quantity measured, temperature actually measured over a time at a certain point, which just gives you a curve. And that's something, it can get more complicated because can you have many of those things, so it can be very large. You can use ParaView for that. There are some techniques for doing that in ParaView, but there are better tools for doing that. If you know how to use graphing tools, maybe even MATLAB or Grapher on Mac or whatever, those programs are usually much better to just graph the data in this sense, right? Then the next thing is that the scalar field can be 2D. And we have seen that the one that we loaded right now, which you see here on the big screen, this is a 2D scalar field, right? It's just on a plane. You have a value, which in this case is the depth there. But it could be anything. It could be a temperature. It could be pressure on a plate, whatever. And there are several techniques how to visualize that. One we have done already. I'm not showing that actually in the slide, but the simplest thing is to use a color map to show what the different depths are, right? So here you see, that the blue parts are really deep down in the Gulf of Aden, and the red things are essentially on the surface, okay? And in between it goes down. So that's a simple way to visualize a 2D scalar field. But another thing is you can of course also graph it like a 1D function, but then it would be just a 2D graph essentially, right? And we're gonna do that in a second in ParaView. ParaView can do that as well. And another very, very often used visualization technique for these kind of things is what's called contouring. That's what you know, for example, from hiking maps or any kind of map, where you see the elevation usually as a contour. And you then know what is meaning a contour is where the height is always the same, right? meaning you know that you here, for example, you have a small mountain, then it goes down very quickly and back up to another mountain here, right? And if you would walk around here, it would go essentially always the same height, but around the mountain essentially. So these are simple ways to visualize 2D fields. And then you can also use ParaView for that, and we're doing that actually, but that's also not the strength of ParaView. ParaView's strength comes when the 3D field and your data is actually 3D, meaning you have a temperature, like say in a room, or like we then later have salinity and temperature in the Red Sea or the Gulf of Aden. So this is the area where ParaView and with these kind of visualization tools, also like visits, where they really shine, right? That's where you really want to use them. If you don't have that kind of data, if you have only 1D or 2D data, you can use ParaView. It might even look a bit better, and you might be able to fancy stuff. But most programs offer options to visualize this kind of data. MATLAB can plot 2D. Mathematica, Maple, they can all plot 2D graphs, and probably also do contouring and things like that. But if it's 3D, like we're going to see in a second when we load the 3D data set, then you want to use ParaView, because this is the strength. Okay, column map done. Then I would move on to this contouring now. So we want to do exactly that, what you've seen before in this height map of the mountains. We want to do now with this bathymetry. So the bathymetry essentially means how deep does it go down of this Gulf of Aden. So meaning contours means we want these lines, which you see here, where you know that along each of these lines you're at the same height on whatever you are, right, or on the same value. In this case, this might be, I think it's actually 0 meters. It's the depth is in meters. Then this one is starting to become yellow, so it's probably around -1,000 meters down in the sea, right? And if you go along this line, you will always be on -1,000 meters. If you start going down here, you will go quickly down to this next level, which probably is around 1,500 meters, and so on, right? So this is what these contour maps mean. And we can do that quickly and easily in ParaView, actually by just pressing one button. And that button is called, it depends. If you have the latest version of ParaView, they changed the tooltips. It's called now, the tooltips just shows generate ISO lines, so ISO surfaces. If you have an older version, it still shows contours. But the button shape is the same, it's just this button. Just press it. Okay? What you should get is, in the pipeline browser, you should see that it now ParaView added what we call another entry, contour 1. So if you add more contours, you can have contour 2, contour 3, and so on. So it's numbered by default. And nothing happened, of course not, because I didn't hit apply. And now I have exactly the problem that I'm on a different tab. I don't see the apply button, so I have to go manually. This in the beginning caused me a lot of headache, by the way. I always thought, why don't I see anything? Where's my apply button? It's in the properties panel, okay? So select the properties panel. Don't hit apply yet. If you've done so, no problem. We can always reapply. We want to change a few. So again, ParaView is not doing anything because it might take a long while to do whatever it has to do now, right? In our case, it will be super fast. It's a small data set. But if you have a huge data set, like the one I talked before earlier, which is 1.5 terabytes, it will take a while to do something on those data sets, right? So this one, it's super easy, it's super small, so it's no problem. But nevertheless, ParaView wants you to hit apply before you do anything. And also the reason is that we can change some parameters for that algorithm. And I actually want to change a few parameters here now because I want to create, so by default, ParaView selects one ISO, what's called an ISO value. That's the contour, that's the value of the contour that you want to generate. So it suggested here -1,500, which probably some algorithm runs in the background to select some value. But this will be just one line. If you look at my slides, I have actually shown a few lines simultaneously at different depths, right? And that's usually a good idea to get an overview of what the scalar field looks like, that you plot all kinds of contours at a certain distance. So let's do, and we can do that in ParaView easily by, first of all, we delete that one or we delete everything what's in values that ParaView suggested. So just press this red X here, then everything should disappear. And then we could add manually levels which we think are interesting, but ParaView actually can do several at once, and that's what I find very useful here. So I want to show that you press this button, and it will give you a range, which is by default is the minimum and maximum value of the variable you have. In our case, it's depth. So we also here see nicely that our range goes from minus 3,000 meters to 0. So deepest part in the Gulf of Aden to here is minus 3,000 meters, and 0 is on the surface, right? And then we want to create a certain number of level sets, and 10 is fine. You actually see the values that ParaView will generate here. So we will generate an ISO contour at 0 meters, at minus 300 meters, at minus 600 meters, and so on. Okay, and it just say generate. And what ParaView does is it just filled these values for you automatically. So you could have done all of them manually by adding plus, 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 and entering the number. But doing this is a shortcut for that. And once you've done that, you hit apply. Okay? So I don't see anything. If any of you should not see anything. And the reason is, it's a bit stupid in my opinion, but the reason is it is there, but you just don't see it. To understand that, let's take a look at the pipeline browser again. So what we have now is we have a bathymetry, which is our image, which we see, and we have these contours that ParaView generated, which we don't see. On the left here, you see these eye icons. They say that that ParaView should actually display this, right? So we're actually showing both of them at the moment. We don't see the contours. So to actually see if there's something there, we can actually just disable the image to not show it. So this button just turns the image on and off, okay? And then you see that it actually did generate the contours. It just colored them in the same color as the image, and then if you plot the image the same color over those lines, you just don't see them. So that's slightly stupid, but here we see now the contours of the bathymetry of the Red Sea. Okay, so this is just a few clicks. Once you're used to that, it takes you a few seconds to just generate all kinds of level sets. To make that pretty, by the way, for those who are still following, and then I'll make a short. I'll give you some time. There's a nice thing to make it prettier. You have to turn on again the advanced properties here on the display, and I always do that when I have lines. I say render lines as tubes and make them a bit thicker. Then I have to next thing. Whatever you do in ParaView, it will do it to whatever you have selected in the pipeline browser. I have selected the bathymetry now, and I changed something, but I'm not showing the bathymetry. Of course, nothing changes because I'm not showing that. And I wanted to do it in the contours anyway. So I want to change this display of the contours. I have to select the contours. I select the advanced properties here, and then I say render lines as tubes, and I make them a bit thicker, and then they are a bit thicker, okay, and look a bit like tubes. That's how you can just make it a bit more useful, the rendering. And that also means that if you turn it back on now, you actually see them because they are a bit thicker now and they stick out of the image, so you now actually see them overlaid on the image. So this is, for example, how you can generate some ISO contours and level sets for a 2D image. Too fast? Everybody following? No one following anymore? Yes, so the question was how did I actually make the lines show up on the image now? So that the problem was that the lines were just lines in the same color as the image was, right? Which you just don't see. So in this case, I mean, there are several options to make them visible. What I did is that I said render them as tubes, which means if I turn off the image for a while, if you turn that off and on, you see I have changed the line width to 3 already. So these are now already big thicker lines. But if I say render them as tubes, it just does some nice 3D shading that it automatically looks a bit like a not just a flat thing, but like a tube, which looks better. And then if you turn on the bathymetry, you actually see them because of that. They stick out a little bit, you see them. But in order to actually show them, you could just change the color. You could just That should work. Now I don't understand why I cannot color that by a solid color. Because I'm again on the wrong. I want to count the contours again. I want to use a solid color here. And then they would be just all white, right? And the problem is if they are now all white, you don't know which one is at which level. But if you show them simultaneously with the map, you can infer it from where they are. That's also a way to make them show. All right. Okay. I want to quickly then show how to map this to a height field, so the actual 2D surface plot essentially of that image. Let's do that quickly. It's actually let's do it quickly. Yeah, let's try to do it quickly. For that, I don't want to see the contours. So for now, I just disable them. You can always delete something in ParaView, but the simplest thing is just to delete them. Now what I want is I want to actually see. I can show that on here. Yes, I want to actually see it as it is. This bathymetry, the depth field as an image, just describes the depth of each pixel essentially of the image where it is. So I want to really see this as a 3D surface. That's the same as this 2D plot, surface plot of some function. In this case, it's just because all the values are negative, it will go down instead of upwards, what your function usually looks like in usual mathematics courses, right? In order to do that, we will need our first filter. So by the way, this is actually called the filter contour. Bathymetry is your data. We applied a filter called contour to it. Now we want to apply a filter to bathymetry that actually maps the depth values to a geometric position where it actually is. And for that, we have to use that filter, and it is called, and this is not here on the toolbars anymore. So the toolbars are just shortcuts to certain filters. We want to use one that's not in the toolbars, so we have to go to filters. Okay, they're again grouped into certain common categories. But if you don't know where it belongs to, under alphabetical, there are all of them. On Mac, that might look different on Windows. On Mac, it's one long list where I can scroll through. On Windows, I might show them all next to each other on one screen, right? But you see that there are a lot of filters that you can, in principle, use. And those that you can actually apply to the data you have loaded. Not every filter makes sense to every kind of data. Those that actually can be applied are bold, and those that are not bold, you cannot even apply to that data. And the one that I want to use here is called warp by Scalar, which it's at the very bottom. W is at the end of the alphabet, warp by Scalar. Not the most intuitive name, but once you understand what it does, go back to the properties. It's actually pretty, yeah, it does make sense to call it that, because it essentially now warps your image by that scalar just in a certain direction, which you can even give here a normal. And we want it to be the C normal, so this is fine. We don't change that. And we want to scale, to warp that by the depth. So we leave the depth here as well. And then we have a scale factor. So let's just see, that sounds all reasonable. Let's just try to do that. Okay, does not look so bad. But there's a small problem. Unless you change something, if you try, so it should be 3D now, right? If you try to rotate now, it just moves around. The reason is that when we loaded only the bathymetry, that was only a 2D image, and then ParaView says, okay, that's just 2D. I use a different kind of interaction than with actual 3D data. But you can always change that, and it's just really just restricting the navigation tools. And the way you go back to 3D is actually here, this little button. So usually you want this to be 3D, okay? And then you see it did that, but this looks super weird and not very useful. And there's another reason. This is what I said in the beginning, is ParaView is a very general purpose tool, but that's how it has its fallbacks. But the problem is that it does not know anything about units. For ParaView, whatever it loads is just a number. And the problem here is that our numbers that describe the image are in latitude, longitude. Okay, these are very large these are very small numbers actually in terms of its values, and the depth then is in meters. So meaning that it's just much too the scaling, the units are wrong essentially. And ParaView doesn't know anything about it. It just knows this is at latitude, I think maybe about 500. This is at 550. And the depth is minus 3,000, right? So it just goes down like that. You just have to tell ParaView what is actually, you have to know your units and you have to scale everything correctly that it then will show up approximately correctly. Meaning, long story short, we have to scale here not by the actual, just by one, just take the actual values, but we have to convert the meters essentially into something that corresponds to latitude, longitude. And you can compute that actually, it would be 0.00025, and I might want to be a bit deeper so that it's not exactly the correct depth. But this value 0.00125 is approximately a good one. If you do that, then you see that you have exactly this height map. Okay. So again, what happened is that you still see the image on top, and at each point, ParaView just moved actually that position there to the value of what you had in your variable, so that you see the depth now as a surface plot, essentially as a graph, as a 2D graph. And in this case, it actually corresponds to exactly the physical appearance of the Gulf of Aden. It's a bit deeper here, so the Gulf of Aden is not really that deep. I exaggerated it a little bit so that we see a bit more what's going on, but it looks much more like the Gulf of Aden. Okay. It looks still a bit different than what you see on the slide, because I removed the top part. I didn't like that. I don't know if you like it, you can leave it, but I don't, because the bathymetry. So it's the data we were given is only the bathymetry, since means it essentially makes only sense where there's actually water. It could here on the outside there would be mountains, right? It could also show the topography. That was not interesting in a simulation, so it just put everything 0. So we have just this flat area. That's not interesting in my opinion, so I just want to get rid of it. There's a quick and easy way to do that with a filter, which is actually here again in the toolbar, which is called clip. So after you have warp, make sure you have your warp by scalar selected. You select the clip filter, which gives you now a way to clip your data. If you just hit apply, you can see immediately what that means. It just clips your data. It just keeps one side at that plane and clips away the other part. That's sometimes interesting and useful to do if you want to see closer inside some data, but that's actually not what I want to do. I wanted to clip just the top part of it. So I can interact with that somehow if I want to. But I find that usually very difficult. You have to find it and rotate, and that doesn't work. You have some presets here. I know that the C normal is what I want, because I wanted a plane that's parallel to XY. And then I know I want it at depth 0, because that's my top part. It actually moved there. If you hit apply, then you have the same thing with just that part removed. But you can clip away in principle anything. So again, you can, and there's a pitfall here too. Now usually what I always do is once you've clipped it, you want to rotate it around because you want to see what that clipped version looks like. And then you rotate somewhere and I moved the clipping plane instead. I wanted to rotate. So first of all, there's a reset button, very helpful. You can always reset your latest thing. And then once I know I like this clip and that's what I'm gonna use it, I disable this show plane. Then it just doesn't show the interaction stuff anymore, and I can rotate any way I want. Okay. Is this should I show everything again, or is it clear here so far? Over there, people are a bit more occupied here. Everything's fine. On YouTube, no one is complaining either. Not yet. Well, then I'll just keep. I'll just show a few more things to finish this 3D visualization now, and then we'll have another short break. And then I'll walk around again. So okay. First of all, let's move on by loading the other data set. The other data set that I provided you is called the Gulf of Aden, which is now the actual data that has been simulated in that area. You just select Gulf of Aden.vts. And here now, for example, you see that we have 3 different variables. Salinity, it's got salt here, temperature, and a variable called vec, which is a vector field. That's why it's called vec. But that you don't see that here, but I know it is. So you could, for example, say I just want to look at salinity and temperature for now. Then I can deselect vectors such as don't even load it, right? But it's small enough we can load all of that. So let's just keep all of them selected and hit apply. And if you do that, another thing that a lot of people get confused first time they use ParaView is now in contrast to the 2D, when we loaded the previous data set, we immediately saw the image with a color map and it was plotted, right? Now in this 3D data set, we actually don't see anything. All that ParaView did is it added this, what we call a bounding box. This is just to show that this is now the area where your data will be. And again, the reason is 3D data can be very large. If it would automatically select some display mode, that might take a long while and you might not want that. So it chooses the easiest and most or safest way to display the data. Just here's where it's going to be. Again, you can see that by that this is actually the Gulf of Aden, because if you turn off the clip, you now see only the Gulf of Aden, and it's only this what is it called? Not quite a cube, almost this 3D volume. So that's probably now a good idea to quickly look at some of the stuff here. This is actually the most. I didn't do it with the bathymetry now because I know the data a lot, and the 2D thing is not so interesting. But the first thing, whenever I load a data set, I look at the information here, just to see what is my data, did it load it correctly, and so on. So you see here the file properties first. What's the name and where did I load it from? That will be different for you, of course. And then some data statistics. That's very interesting, especially for simulation people and computer scientists and people like that. We want to know how large our data actually is. And here you see it's whatever structured curvilinear grid is not so important to know now, but it's a kind of a grid. And it has about 1.5 million cells and points each, right? So to a simulation guy and a computer scientist that needs something, that's about the size of your data. What's definitely interesting is how large your data is, how much memory it takes up. In our case, it's super small. No one should have problems with 90 megabytes these days. But volumetric data, just think about if you increase the size in each direction, you double the size in each direction, the size of the volume will go up by 8, right? So it's volumes get pretty quick, pretty easily. So that's why this one is rather easy. It's rather small. And interesting is also the bounds. These are the physical bounds of where your data is. So in this case, in X direction, if I rotate to X a little bit, we go from 42 to 49. Okay. In Y direction, which is actually this one here, we go to 10 to 15. If there are any geophysicists or whatever you call these people here, they might recognize these numbers. This is actually the latitude and longitude on the Earth where the Gulf of Aden is. So this is really physically the region where the Gulf of Aden is. And that's what I said before. In the bounds in C are from because I already scaled it. So this is already corrected. I scaled it correctly. It's going from almost 0 to minus 3 approximately. Since we scaled by, what did we scale? About 1,000, a bit less than 1,000, meaning this is actually going to minus 3,000 meters. So these bounds are very interesting to know where your data actually is. And if you're a computer scientist, you might be interested in what the dimension of your data exactly is. If you're not, it's not for visualization purposes. For using ParaView, it's not that important. So, but now we want to see something, right? We wanna know what is actually in our data. One thing, the simplest thing you can usually do with 3D data is you just slice through it, because then you have a plane again, and on that plane you can just display things the way you did before with that image. And for slicing, there's a button here called Slice Datasets with Planes. It's right next to a clip, okay? You slice, and it's exactly the same interaction as before. You have a widget which you can use to change your plane or not interactively, which never works nicely for me. Never hit it. Here it is. So I could move it left or right. I could rotate it. I'm gonna I cannot reset it anymore. Doesn't matter. I use the X normal again. It's still the same. Okay. Let's just hit it. Again, to make sure I'm happy with the plane. I don't want to move it anymore. I disable the show plane. Done. Now I can interact as I want. And still we're not seeing a lot. Pretty disappointing, right? Now the reason is that ParaView chose not to display anything, which I don't understand quite. So it chose to, by default, use a solid color for that slice. But of course, we want to see one of our variables there, right? So you can now, for example, look at salinity or a temperature, and they both look, that looks actually pretty interesting already, and reasonable, right? Because this is the temperature in the Gulf of Aden. Here you are at the surface level, where it's comparatively hot, and the deeper you go down, the cooler it gets. That sounds reasonable. So it seems like the simulation did something corresponding to reality. But you see that there is some variation in between, which might be interesting in the temperature. But another problem here is, I want to quickly show that too, especially if you go back to salinity. That doesn't look very interesting. It looks weird, right? Because it's just one value essentially, and nothing else. And it's actually not true. The problem is that if you turn on your bathymetry again, you see that this is exactly where it's inside the Gulf of Aden, and it's just blue everything outside. Which means that again, the simulation was only interested in the parts inside the Gulf of Aden, so it just set everything outside to 0. But now the problem with salinity is the salinity goes from about 30 to 35. And our color map now goes from 0 to 30 or 37 actually. So it's just showing things that are not interesting. There are a few ways to fix that. And one thing is that you can change the scale, the range of your color map. Okay, so this would be this button here with the little C for custom range. So you see that this was again the wrong filter. I don't want to apply that to clip. I want to apply that to my slice. Okay. Always make sure you have selected the correct thing in your pipeline browser where you want to do something. If I do it here, now I see the range that ParaView chose is just the minimum to maximum of the salinity, which is from 0 to not quite 37. But the problem is that the salinity only starts at about 33. And everything else is 0 because it was not interesting. So I'm actually only interested in the range 33 to 36. Let's go there. And now it looks already much more interesting. The problem is that I have to know that range. I don't really know that range. I could figure it out, but computer scientists are lazy. We want to do things automatically. So one way to do it. By the way, if you want to scale back to your original data range, you can always use this button here, rescale to the data range. Now, if I press that, it goes back to 0, 36, which means we don't see much. But in order to avoid this rescaling all the time, I can actually extract only the data I'm interested in, right? I'm not interested in all those zeros anyway, so I'm just clip them away. And that's actually, I have to do that on my data. I have to select this one. This is a filter called here. It's, again, depending on the ParaView version you use, it might still be called threshold. Now the pop-up says extract cells that satisfy a threshold criterion. And the filter that corresponds to it is actually called thresholding, I think. It's here. It's this one. So it has actually the icon next to it. So the filter is actually called threshold. The tooltip here says extract cells that satisfy a threshold criteria. So if we do that, go back to properties. I only want that region in the Gulf of Aden where the salinity is something interesting, and that's everything that's not zero. So I can actually threshold by any value big larger than zero, because salinity, I know it starts to be interesting only at about 33, I think, maybe 30. I don't care. I know at 2 there's no interesting salinity, so I can just threshold that by 2. And then let me disable everything else. You see that ParaView now actually created, but this is now really still a volumetric mesh, but only of that area where your salinity is actually not zero. So that's an easy way to get only the region that you're interested in. And it is, of course, if you turn on the clip, your bathymetry again, it's exactly the region that's inside your bathymetry. Not completely accurate down there, but essentially the region that's inside your bathymetry. Okay. And the advantage of that is if I slice this one now, I don't have to rescale anything anymore, because it already has an interesting range. Although ParaView always chooses not to display anything by default, I go to display and select the salinity. And it did not automatically rescale out. That's interesting. So you always, I use this button a lot, by the way. Always rescale to your data range, because then you see what's there. It might, as in the case of salinity, not be the right choice, but at least you know what's there. And here you see your salinity. Let me, in the slice, in the properties, turn off the plane again. I keep that slice here. And there you see the salinity at that slice here in that region of the Gulf of Aden, what the salinity on that slice looks like. And to me, I don't know exactly what it is. I'm not a domain scientist, but I could assume that this actually looks really quite interesting, that the salinity is low on top, then gets high again, and then gets lower again. Okay, so these are the kind of things that you can see by doing this. And quickly, before we make another short break, of course you can add several filters to the same data set, and for example, now slice also in a different direction. I want to do that. Let's slice once more, because let's say I also want to know what it looks like on top. I want to slice with a horizontal slice now, so I know this will be the C normal. Let me zoom out a little bit, but that's too low. I want it to be slightly below the surface, just very slightly, 0.001. Let's make it 0.01. I think it doesn't matter. And hit apply. Okay, so we got something. It's there. I turn off the plane. I don't need it anymore. And I display something on that slice. And I'm actually, again, interested in salinity. And here you see the salinity now on the top slice. So essentially on the surface of the Gulf of Aden and a little bit of the Red Sea. And that's also interesting, but makes much more sense to me, actually, is that the salinity in the Red Sea is obviously much higher than in the Gulf of Aden. That makes sense, because the Red Sea is much shallower than the Gulf of Aden. Okay, let's have a short break again, and I'll go quickly through and see if I can help with stuff. Go ahead. Okay, welcome back, everybody. We are running a bit out of time, so I will I just want to show quickly how to do a little bit of flow visualization, because that's important. That's probably interesting to most of you. If you haven't completely managed to reproduce everything I've done here so far, I'll say a little bit afterwards for those people who are here, and we can work on that. But let's quickly go to at least a few simple things in vector field visualization. And the things I'm doing is just two simple techniques. It's one is called arrow plots and the others are streamlines. Arrow plots are super easy, I think, to understand if you know what your data is. So like vector fields, as I said, it's the movement of water. In our case, it's literally the movement of the water in the Gulf of Aden. It could be wind, it could be an electromagnetic field, which are also vector fields. So anything that's a vector, you know that at a certain position you have a vector. That's why I call it a vector field. Essentially an arrow pointing in a certain direction. And the simplest visualization technique is just to plot a few of those. You cannot plot everything because they are all over the place at each position. But you can plot a few of them, or at least those which are on your grid points. That's usually much far too many anyway, but you just plot an arrow there. And we'll do that. That's super easy and fast. And you get already an idea of what your vector field looks like. And the other technique is called streamlines. So a streamline is essentially a line now that is always following the vector field, like you see it here in the picture. This can be done more mathematically, of course, like in terms of differential equations, and you have to solve it, and you can have lots of numerical techniques to do that. Does not concern us right here now. All we want to know is how to actually display it, because ParaView can compute these streamlines for us. And I think the best way is just to take a quick look of how it works. In order to do that, what I'm going to do is I'll disable everything except my bathymetry for now. And also, I should have done that before, I think. I don't like the color map for actual, once it's warped, I don't like that color map that much anymore. So I'm going to change that one to something a bit, this one, something a bit less psychedelic. And there is something, I like this brown thingy, because it looks like what the Gulf of Aden might look without the water. I don't know. So if we look at, from now on, I'll work with this thresholded version of my data, which means this is essentially only the region where there's something interesting, only the region that's inside the Gulf of Aden. That's easier. But that by itself doesn't really show much. But I can go to the information to see actually, by the way, now what happened when it thresholded. First of all, you see that it got much smaller, right? Before it was 1.5 million points and cells, and now it's only about 400,000 cells in water. That's always a good idea when you visualize something. Threshold and clip or extract subsets of only the region you're interested in. The smaller the data, the better. There might be some problems because we actually have converted now into an unstructured grid that's a bit less efficient than the other grid, but at this size it doesn't really matter. It makes the visualization a bit easier. So when you keep doing that, you should get the feeling of what's useful to do or what not. But usually, it's the smaller you can make your data, the better. And then what I can do is I just want to show a few arrows, okay, to see the vector field. So by the way, we see the vector field here. We have our salinity and temperature and the vector field. By the way, you can see that it's a vector field. I have to make that larger here. The display here of ParaView shows you the range of your variables. So again, here we see actually salinity is between 34 and 40. Temperature is between 2 and 29. And then the vectors are actually, we have three ranges, meaning we have three components of that variable, right? We have an X, Y, Z component, U, V, W, whatever you want to call it. But it's just the ranges of the vectors in each direction. So here you can see that this is actually a vector variable. Let me make that smaller again. And to display a few arrows is super simple. Again, just apply one filter, and the filter is exposed as a tooltip in the toolbar, and it's called glyph. And the tooltip now, and new tooltips say generate glyphs that represent attributes in input data. Let's just do that. hit that button. Make sure you had threshold selected before. You should get a display like that. Actually, for now, I can turn off the advanced options. The regular options are good enough for what I want to do. You can choose a few glyph types, but for this kind of vectorization, and I even called it an arrow plot. Arrow is possibly the best choice, so I keep it at arrow. The orientation array, you can choose. You could have several vector fields in the data array. We have only one, so we can just choose this. We could choose no orientation array, but that would make no sense, right? And we don't see anything. We choose our vector array. This one is a bit more difficult to explain, but you probably often want to scale your arrows because they might be too large, too small, to show nicely. And here, you can choose that scaling. It's just a bit unintuitive because if I say no scale array, ParaView will actually normalize the vectors, which for me is a bit unintuitive. It should not do that. But that's how it is. If you say no scale array, it will normalize it. That's not what I want. I want to see the vectors at their actual length. So I actually have to scale them by their own vector magnitude. That's a bit, I don't know who had that idea, but that's how it is. If you don't scale your vectors, they get normalized. If you want them to display as they are, you have to scale them by their own length. And then this is scale by magnitude. The scale factor, we have to figure out how to, which one is a good factor. You can only do that experimentally. And then you can say how many arrows do you want. That's also something which is difficult to say. ParaView suggests something, so I would say we just try that and see what it looks like. If you do that, you should get something like that. It's actually not so bad, in my opinion. You see that you have your arrows all inside the Gulf of Aden. You see a little bit, maybe you don't see enough. Maybe it's not enough arrows. Let's make 3 times as many, 15,000. That's a bit better. That's a trade-off again. If you plot a lot of arrows, then it will get super slow. By the way, you have the option here, so it says uniform spatial distribution, meaning it will randomly select 15,000 positions inside your data set to put the arrows at, right? You could select that you want to put an arrow at every grid point that you have. But we have a few million grid points, I think, so this is not a good idea to do, right? You could use every endpoint to skip a few things, but the best thing to find a good, nice first view of what your vector field looks like is to just do a random sampling, choose the number of points that you want, and then you could even try play around. Maybe the scaling makes it a bit better to see what's going on. Few things that are interesting is also look reasonable to me is that here where you go to the Arabian Sea, essentially where you go into the open water, the vectors seem to get larger, so the velocities of the water gets higher. That seems to be reasonable. And another thing that's interesting is that you seem to have what these people who simulate that they call eddies, meaning circular motion in the inside that small region that you have. That also makes sense, right? Water is flowing in, it has to go out somewhere again. In between, it has to rotate. And there seem to be at least 3 or something like that, but it's difficult to see. And you see immediately the problem with these arrow plots is it's not easy to really say, for example, if you look at this region, there's an arrow going in this direction, but is this one before or behind it? Which direction is it exactly pointing because it's projected on the screen, right? So this is hard to say. Not so easy to really understand what's going on. What you might already see is that most of the motion in this Gulf of Aden is actually in the XY plane. There's not that much motion going up and down. Okay. Yes. So this is in 3D arrow plots. You get an overview of what your vector field looks like, but maybe it's better to again cut it down a little bit. And one thing you can always do also is, and that's the nice thing in ParaView, you can just plot these glyphs not on your whole data set, but on something you extracted from. So for example, we can use this slice 3 that I had and only plot the vectors there, right? then I'm not going to see any other vectors. And the only difference that you have to do is you don't have to use a different filter or anything. It just depends on what you have selected when you apply your filter. So if I select, instead of selecting the whole data set, which was the thresholded thing, I select a slice, and then I plot the vectors. Again, I want to see the vector length actually. Let's stay again with 5,000 points. I only get vectors on that plane, right? So I don't have any other vectors now. They are only on the plane. And there you see a bit, that's easier to see what's going on. In this case, not sure, because ParaView chooses to color them again by the color I have already on the slice, which in this case, in my opinion, is not very useful. So here I want actually the arrows to be solid color. Just so you can also, for example, color them by their magnitude. That's often an interesting thing to know, right? And you immediately, that's redundantly coded because the length of the arrow already says what's the magnitude of it is. But if you see it also in color now, you immediately see where your high speed regions are over here and build it over here. You just have to make sure you're not confusing it with the color map of the salinity over here. This is different. You might want to use a different color map actually. You should use a different color map. Let me do that. You should use a different color map here. What's this? This is cool to warm, right? But a magnitude, because everyone likes the rainbow colors. But now it's a bit less confusing that we have two color maps. One color map displays the salinity, the other color map displays the velocity of the vectors. Or to be on the safe side, just make them in a single color, and then you see here, for example, much better, at least on the surface. So this is the disadvantage. You don't see your whole data set, but in this case, it might be interesting to see just the surface. You see that you have obviously three eddies next to each other, and it also makes sense. This one is counterclockwise. This is other way around. This is clockwise. This is counterclockwise, and this is also counterclockwise. That's interesting. Anyway, that might be interesting for the people who simulate that and for the domain scientists. Also interesting is that here in this small street, whatever it's called, Al-Mandeb, some Arabs here, sorry, I'm not so good in that. Things have to speed up again, right, to go through it, and then they get slower again. So all makes sense and all gives you insight in what you're actually doing. Okay, that's arrow plots. So important, easy to use, just a few clicks in ParaView, not easy to interpret, especially in 3D, easier in 2D. If your data is for some reason only 2D anyway, then arrow plots are usually a pretty good thing. Can't get much better. In 3D, there are some better things, and one thing is, and let me show that now quickly as the last thing, is what's called streamlines. So streamlines, again, are actually lines that are always just following usually the intuitive explanation you usually give is you drop something light without almost no mass into a flow field, water that's flowing, then the line that particle would trace out is the streamline, right? Not quite true for physical things because they change over time, and the streamline is instantaneous at one time step. So visualizing with streamlines can be difficult and dangerous, but let's not worry about that at the moment too much. We're just going to do that for this data set. Actually, the current is changing in this Gulf of Aden, of course, but it's changing rather slowly anyway. So it might not be too off. It's a little bit off, but let's just see what the streamlines look like. And in order to do that, also super simple in principle, but a bit more difficult to get something interesting out of it. Let me disable the slices. So again, I have only the thing. The filter to use is just called Stream Tracer, if you know that, and the glyph or the toolbar thing you have is here. That's what I don't like about these new tooltips, is that now I don't know what the filter is called in here actually. So here it's actually called Stream Tracer. Stream Tracer, this one, it has the same icon next to it, but you have to essentially know it. So if I I think I had the wrong thing selected again, right? I have to use my threshold data, of course, again. Now I just use the toolbar thing. And hit stream tracer. Okay, so what you see is that ParaView added this, not much happened again, but it added this line. What's that line there for? The problem is the same as with arrow plots is you have to tell ParaView somehow where to put the arrows. You have to tell it especially where to put the arrow, each arrow. Now we just set randomly somewhere. That's fine. With the streamline, it's a bit difficult. You have a bit more difficult. You have to tell ParaView where to start the streamline, right? And that's not so easy to choose because you don't know where the streamline will go. So if you say I put one here and you put another one here, they might just overlap because they might be by accident just on the same streamline, right? And if you put some streamlines, start some streamlines here, everything would move over here. You won't see anything that's going over here, over here. So this is one of the problems with streamlines, but and ParaView gives a few easy things to what's called streamline seeds, and this is this line. So it will on a certain number of points, which you can set at the bottom of this panel, it will just start the streamline. Okay. And this might even be actually quite useful for our data because maybe it's actually interesting to start streamlines just in this Gulf of Aden area. The problem is it's pretty difficult. You can try it yourself to get a line, do something you want by this 3D interaction by dragging its points around. They're always on the wrong. They always end up somewhere wrong. So what the trick I do usually is I go to View and change my projection to where is it? Parallel projection. So I don't get any perspective anymore. Then I can move. By the way, these buttons just align your views with the coordinate axis. Okay, they are super useful. Then I can just use these buttons to align with the coordinate axis and try to find a position of the line. So now from top, it's nicely inside the gulf. I look at it from the side. I don't see it because it's inside my bathymetry. There's a trick for doing that as well. I can go to the clip, go to display, and turn down the opacity. Then it gets transparent. I should see that line, but I don't. Because I don't have it selected. The line only shows when you have your there it is, when you have your actual stream tracer selected. So I can move it. I want to start this. Let's say I want to start the streamlines a bit on the top. Not completely, so to be sure to be still inside the data set. And let's try the third axis. That looks nice because from top we're inside. Looks reasonable, okay? Go back to properties. Now we could hit apply already. The problem is here it says start 1,000 streamlines. That's the default value ParaView usually uses. 1,000 streamlines is a lot. I would start with a lot fewer. Hundreds are usually enough. And just hit apply. Something happened. Something happened. Okay. So that's what you. Again, not should change this anymore. I can disable the line. So now you see the streamlines that have been, if you show the line at 500, no, at 100 points along that line, ParaView started the streamline and integrate the streamline, right? So what you can see is that in this case, not so bad because we see actually we have 4 eddies, it seems. With the arrow plots, I only saw 3. And they are nicely captured, but still you might think, nothing is going into the Red Sea, which it should be probably, so you might want to seed more streamlines over here. And also if you look at it from the side, although we actually see that in 3D, as I said, the movement in the Gulf of Aden is not really going up and down a lot. So we essentially just got streamlines in, just where we seeded them. That's what it is. Okay. I'll take a bit longer, I guess, as I intended to, because let's make another quick break. Let's have another quick break, and I'll wrap up afterwards. With we'll just take 5-10 minutes afterwards, but with 10 minutes break, we might be 10 to 15 minutes longer. Okay, let's have a quick break now. We'll be back and wrap up. Very welcome. Oh, I said press transitions, okay? All right, so I want to wrap up now. Actually, for that, I'm going to switch back to my slides. I could have done that before. So these were the streamline techniques, the arrow plots and the streamlines we looked at. I could talk a little bit about certain ParaView GUI and features, but I think actually they're pretty easy to figure out yourself. But the most things you most often and most likely will use is making screenshots, of course. Easy, it's just a button. Very important that you can load and save states. So when you have a visualization you like, you save it as a state, and then you can just reload it at a later time. Do that often because ParaView doesn't have, first, you don't have any undo function, and it does sometimes crash. And it doesn't have any recovery mechanism. So really, if you have done a lot of work on something, save it. There are also advanced things which are often used for like multiple linked views for stuff. I think I've talked about that on previous workshops that we've recorded. For the sake of time, I want to wrap it up. So I hope that some of you got out a little bit, at least an idea what ParaView can do. If it is useful, what you can do. You won't be a ParaView expert yet. It took me years to know a lot of stuff, and I don't know everything. So if you have any questions, let us know. We have a lot of experience these days, and we might be able to help you. But these are the kind of things that you can do with ParaView. You can think it could be different data, different vector fields, but essentially it will be these kind of techniques that you will do. And to end, I want to again advertise a little bit our workshops that we're doing this semester. So this was just an introduction. There are some more service workshops next week is about the segmentation, as I said at the beginning, if you're interested in these things. If you're using Ibex or Shaheen, please go to this onboarding session. You will definitely need that. And if you're doing data science or need data science, if you need to know, if you use Ibex and Shaheen, you will need to know how to use a shell, for example. Then you should also, might be interesting to look at those workshops on Shell, Conda, Python, and then more advanced things on machine learning, deep learning, and these kind of things. I think this is my last slide. I want to thank everybody and see you maybe in one of the next workshops. Thank you.